I hope everybody's doing well. This is a second video on optimization, and we're going to deal with a rectangle, but in a slightly different way. So in this particular problem, I want to give you a rectangle with a fixed area. In other words, this area is always going to be 36 square inches. The question that I have for you now is, what are the dimensions of the rectangle with the smallest perimeter given that the area is 36? So if I have a rectangle, I know that the perimeter is 2x plus 2y. Oh, be really, really careful that you label your pictures. Please do that. Without the labeling, these letters do not make any sense. The perimeter is 2x plus 2y, and my area, since I'm asking you to always fix it at 36, I'm going to write down 36 equals x times y. So my given, 36 equals x times y. Again, like in the last problem, I want to isolate one of the variables. And in fact, this time, I decided to solve for y. So I write down the perimeter in terms of two variables, 2x plus 2y. Now I can replace one of those variables. I can replace the variable y by 36 over x. Doing a quick little calculation, I wind up getting that the perimeter is only dependent on one variable. And that's a good thing for us because now we can use the techniques that we have done previously. Again, the goal is to maximize p of x, but unlike the other problem, this is not a closed interval problem because I can make y as big as I want as long as I compensate with x so that the product is always 36. I can make x as big as I want because I can make y really small. There's no constraint on x other than it has to be positive because I can't have a negative dimension. So this is an open interval problem. So the closed interval method that we used in the last rectangle problem will not work. Again, we want to figure out critical values. Here's my function taking a derivative. And yeah, I had a little typo when I was writing this. I want to set this derivative equal to 0. And when I set it equal to 0, I wind up getting the equation 2 is equal to 72 divided by x squared. Or in other words, x squared is equal to 36. This produces two solutions. X is equal to positive 6, x is equal to negative 6. But since we know x is positive, we have x is equal to 6. And if we go back up to here, we know that y is also equal to 6. Because 36 divided by 6, well, that's 6. But that is just a possible answer. We need to check if it produces x equals 6 produces a minimum. So going and using the first derivative line, in other words, a first derivative test, plugging in a value less than 6, let's pick 1. If I plug 1 into here, if I plug 1 into here, do I get a positive or negative answer? On the first derivative line, we wind up getting a negative first derivative. If I plug a value bigger than 6 into here, then I get a positive answer. So I know p is decreasing on this side, p is increasing on this side, and I really want you to write these conclusions down. Since p goes from decreasing to increasing at x equals 6, we know x equals 6 produces a minimum. Now let me go back up to the question really quickly. It says, what are the dimensions? So my final answer is a rectangle that is 6 by 6. That has an area of 36, but that is the smallest perimeter that we can obtain. I hope that was helpful. If you have any questions, let me know.